Now, to pick up where we left off in the last video, but we're going to now finish out the rest of our notes that are talking about multiplying and dividing, basically, radical expressions. We covered multiplying yesterday. Today, we're going to cover dividing. But first, we need to take a small pit stop and talk about conjugates. Okay? And a conjugate essentially is if I have A plus B, then its conjugate is A minus B. Okay? Furthermore, their product is always a rational number. So conjugate is just a fancy way of saying I want you to take the inverse operation of that and multiply it by itself. That's all it's really telling you to do. Okay? So, yeah, rational numbers. Now, the shortcut to this is basically this. Is a squared minus b squared. If you take the square roots of the a and the b term and then subtract them in the middle, the squares of the first and the a and the b terms, you'll get the same answer. I will show you this comparable, obviously, in an example. No one comes back. Okay, so you have 5 minus 2 radical 3, and you have 5 plus 2 radical 3. Okay, so there is our conjugate of the subtraction. So we take our first term and our last term of one of them, doesn't matter which, and we're going to square them. So we're going to do 5 squared, and we're going to do 2 radical 3 squared. Okay, 2 radical 3 squared basically is just going to give you 12. And the reason why is because when you take the square root of those numbers, the square is going to cancel out, right? Square root of a square is canceled. And 2 squared becomes 4. So you have 4 times 3, which gives you 12. I will show that instead of just writing the answer. Hold on. So you have 4 squared. So basically you're distributing this to both terms. So you have 4 squared, square root of 3, squared, squares cancel. So you have, sorry, I meant to write 2 there. Then you have 4, and you have times 3, which gives you 12. This gives me 25. Remember, the shortcut says minus. So even if this was negative or positive, it wouldn't matter. You always will subtract on this shortcut, okay? So that leaves you then with the term or the answer of 13, because 25 minus 12 is 13, okay? Okay? Does that make sense so far? Okay, great. Now, why do we need to know this? Because now we're going to talk about dividing radical and rational expressions. Okay? So, and we do this by rationalizing. Okay? Which is multiplying the numerator and denominator by the same expression. Okay? With the conjugate of the denominator. Okay? Remember, when we hear the word conjugate, all it's basically saying is this: to flip the operation of the expression. Okay. So that is what we're going to be using when we divide now. So we covered multiplication of radicals. Now we're going to divide radicals, okay? And we need to know what a conjugate is in order to do that, because that's how we simplify them, okay? The big rule of dividing radicals is we don't want radicals in the denominator when we are done, okay? So, for example, we have 5 over 3 plus radical 2. We're going to multiply that by the conjugate of the denominator, which is going to be 3 minus radical 2. 3 minus radical 2. So, on the bottom, we use our shortcut from last time again. I'm just going to put F for first, L for last. First would be 3 squared, which is going to give me 9. And the last would be square root of 2 squared, which is going to give me 2. Then we just subtract these two numbers to get 7. On the top, we're just going to distribute the top numbers. On the top, then we distribute, we get 15 minus 5 radical 2, and there is my answer. Okay? And that's how we solve these. Okay? All right, so last thing we got to do, one more example. Okay? This one's going to be a little more complex, though. 2 square root of 3 over 4 minus radical 3. So instead of just having a whole number up top, now we're going to have essentially a polynomial, a radical expression times no radical expression that we're going to have to FOIL, or box method, or distribute, whichever one you want to do. Okay? So, first things first, let's take the conjugate, which would be 4 plus radical 3 and 4 plus radical 3. First for F, L for last. For our first term, we have 3 squared. Whoops, I was reading the wrong one. Okay, my bad. For our first term, we have 4 squared. And for our last, we have the square root of 3 squared. We're going to get 16 out of this, and we're going to get 3 out of this. 16 minus 3 is going to give me 13. On the top, we're going to distribute that. So 2 distributed to 8 would be, sorry, I just said the answer. 2 distributed to 4 is 8, plus 2 radical 3. Negative radical 3 times 4 is plus 4 radical 3. And radical 3 times radical 3. Again, if you refer back to our notes from yesterday, I talked about what happens when you multiply two radicals that are identical, both in their radicand and in their index. They just become that number, meaning that you don't have to worry about all this other mess. Sorry, right here, all this other mess. You just get plus 3, and that is it. Okay? Also, on a side note, I think I had a typo yesterday. Did I write it on here, or is it on that last multiplication one?
So we're done?
No, not yet. Almost. I can't find it right now, but I will address the typo at some point. But, so we have plus 3. Great. So now we just got to combine like terms. Okay. So we get 8 plus 3 is equivalent to 11, plus 2 square root of 3 plus 4 square root of 3. The square root of 3s are just along for the ride like any other x. We're not going to mess with them. We're just going to add the coefficients because they're the same. And we get 6 radical 3 over 13. And now we're done. That is our final answer right there. All right? Good luck. And make sure you guys do your classwork.